Hello, I am Hari, and a physics teacher. This is the second part of vectors. It is my second video regarding vectors, and let us see resolution of vectors. Resolution of a vector. Resolving a vector means splitting the vector into two component vectors, usually one horizontal and one vertical, that is x and y components. These two vectors have the same effect as the original vector. Resolution of a vector is simply a process by which we find two vectors which, when added, gives the vector. Any two vectors whose vector sum equals a given vector are called the components of a vector. For example, vector A can be resolved into two components, namely ax, meaning A in the x direction or in the horizontal direction, and ay, A in the y direction. This vector is resolved in this way. We draw a horizontal line for ax. We also draw a vertical line. Now, right angle triangle is formed. This is the horizontal component of vector A, and this is the vertical component of vector A. The angle that the vector A forms with the horizontal is theta. Sin theta, opposite over hypotenuse, ay over A, which implies ay is a sin theta. This is the vertical component of vector A. So the vertical component of vector A is a sin theta. Cosine theta is adjacent side over hypotenuse side. The adjacent side is ax, the hypotenuse side is A. This implies that ax, or the horizontal component of A, is a cos theta. Tan theta is equal to opposite side over adjacent side, or simply sin theta over cos theta, which is ay, which is just the opposite side over ax. Look here, ax is the adjacent side of theta, which is the adjacent side, ay is opposite side to theta, and A is the hypotenuse side. This is a right angle triangle. The direction of ax is to the right, the direction of ay is upward, and this forms a right angle triangle, and thus ay is a sin theta, ax is a cos theta, and tan theta is ay over x. Vector A is the vector sum of the two component vectors. In vector sum, vector A, that is a vector A is equal to ax plus ay. This is vector sum. It is not the result, the resultant or the value. The magnitude of the resultant vector can be computed from Pythagoras Theorem. Do you know why? Because ax and ay forms an angle of 90 degrees with each other, and thus the resultant vector A is a squared is equal to ax squared plus ay squared, or simply norm of A is equal to square root of ax squared plus ay squared. The direction of A can be found from tan theta as tan theta is equal to ay over ax, meaning theta is tan inverse of ay over ax. Let us prove the cosine law by using a resolution of vectors A and B into components. B and A are given. They are connected tail to tail. They form an angle theta with each other. What we are going to do is proving the cosine law. We have said that the resultant of any two vectors that are connected to tail to tail and form an angle theta between them is square root of a square plus b square plus 2ab cos theta. Now is the time to drive it. Let us see. Vectors A and B connected tail to tail, making an angle theta. Now A is resolved. Here is the horizontal component of ax. Ax is a cos theta. We have seen it before. Ay is a sin theta. It is in the upward direction. We have said that the component vectors should always be connected from head to tail. and the resultant vector tail to head. So the resultant vector is connected from tail of ax to head of ay, and A is resolved. Now B is resolved. B is simply bx. Bx no, because it has no vertical component. By is 0. Adding the component vectors gives, here is ax plus bx, which is resultant of x. The resultant of the two vectors in the x direction is rx, ax plus bx, or simply ax plus b, because b is equal to bx. We have no vertical component of b. The magnitude of the resultant vector r can be computed from Pythagoras theorem as r resultant is equal to rx squared plus ry squared. How? We have found rx, which is the sum of ax and b, but ry is not still computed. Let us see it, adding the y component vectors. Here is ay, which is a sine theta. It is in the upward direction. And we have no by, because by is 0. So the resultant in the y direction is only ay. As a result, the resultant vector r then becomes total r, or total resultant is r in the x direction plus r in the y direction. Note that rx and ry forms an angle of 90 degrees. If they form an angle of 90 degrees with each other, the total resultant r is r squared is equal to rx squared plus ry squared. So the magnitude of the resultant vector r can be computed from Pythagoras theorem as r is square root of rx squared plus ry squared. We know that rx is the sum of x plus bx, so this sum is squared, and plus ry is simply ay, so it is ay squared. Then r is x plus b squared plus ay squared, because bx is equal to b. The resultant vector is now ax squared plus 2axb plus b squared plus ax squared. Do you know why? This is ax plus b is multiplied by itself. Ax plus b, when it is multiplied by itself, gives ax squared plus 2axb plus b squared. Now the resultant becomes b squared, which is b squared, plus 2axb, which is 2xb, plus ax squared plus ay squared, because addition is commutative. Ax squared plus ay squared. Now the resultant becomes b squared plus 2ab cos theta plus a squared. Do you know why? A squared is the sum of x squared and ay squared. Therefore, the resultant vector becomes square root of a square plus b square plus 2ab cos theta. Now it is proved. Now Cosine Law is proved. Have you seen it very well? Good. Let us continue. Let us say another example. Find the resultant of the following concurrent forces. 3 forces are acting at the same point. Hence, these 3 forces are concurrent forces. F1 in the downward direction, F2 to the right, and F3 making an angle of 37 degrees to the horizontal. The magnitudes are F1 10 Newton, F2 20 Newton, and F3 40 Newton. These are concurrent forces. Let us find the resultant of these 3 forces. Solution. Resolving each force into components gives. This is easy way to find the resultant of any force or concurrent forces. Forces, x component and y component forces. Look, the forces given are F1, F2 and F3. And here is the resultant. F1, F1, F2, F1 has only y component but not x component, because it is directed downward, and it is F1y is negative 10 because it is in the downward direction. and f1x is 0 because it makes an angle of 90 degrees with the horizontal, and cosine of 90 degrees cosine of 90 degree is 0. So f1 has no f1x component, but it has f1y component, and by convention in the downward direction is taken to be negative. That is why negative 10. When you come to f2 has only x component, which is to the right and it's positive, but it has no y component. Let us see the table. f2 cos 0 degree, it is 20 Newton because cos 0 degree is 1. But f2y sine 0 degree is 0, hence it has no y component and it has x component. It is positive because it is to the right. When we come to f3 has two components. We need to resolve f3 into horizontal and vertical components. Let us resolve it into horizontal and vertical components as follows. f3x is f3 cos 37 degree, which is 40 Newton times cos 37 degree, 0.8, 32 Newton to the right. f3y is f3 sin 37 degree, 40 Newton times 0.6, which is 24 Newton. The resultant or net force is, let us add the x component forces, meaning fx is f1x plus f2x plus f3x. 20 Newton plus 32 Newton plus 0 Newton, which is 52 Newton. So the resultant force in the x direction is 52 Newton. When you add the y component forces, fy is f1y plus f2y plus f3y, which is 14 Newton. Therefore, the net force is square root of fx square plus fy square. As I told you before, always x and y components form an angle of 90 degrees with each other. As a result, we need to use Pythagoras Theorem in solving these problems and finding the value of the net force. So 15 Newton square plus 14 Newton square, which is 53.85 Newton. This is the resultant. This is a mechanism by which the above forces can be resolved. Or the x component forces and the y component forces are explained one by one in these figures. So have a look at all these figures. I have already described it before. This is the next part of the resultant. The resultant of x component and y component force is shown in the overall resultant is here. The direction of f can be found from the tangent function. That is, tan alpha is fy, meaning opposite, over fx adjacent. Opposite over adjacent is tan alpha. 14 Newton over 52 Newton, which is 0.27. Alpha is tan inverse of 0.27. You can find it from the back of your mathematics subject, and the result you obtain is 15 degree. Therefore, the net force is 53.85 Newton, and the direction of the net force is 15 degree above the horizontal. This is the solution. These are review questions. 1. Read the questions properly, and the solutions will be released at the end. This figure belongs to question number 8, and this figure is for question number 7. This is the figure for question number 8. These are answers for review questions 1, and look at the answers properly, and if you have questions or suggestions, you are welcome. Thank you for listening. Subscribe and share it. Thank you.
And don't forget to subscribe and share for your friends to get the next consecutive videos.